Hello and welcome to the second episode in this video series on the common emitter transistor amplifier. In the first video we went over some high-level concepts, and now we're going to get into more details of how we can keep our transistor on and linear. To move forward, we need to understand the relationship between alternating and direct current. We will start by looking at a graph of the output. We have the DC offset and the AC output signal. The AC output signal varies about the DC offset, so it swings above and below it relative to the DC output offset. We need to design the circuit so that our output signal can swing below and above that DC offset, but not be distorted by either going too low or too high. If the DC offset relative to the output is too low, we see that the AC output signal will be distorted. This is called clipping. In the portion where the output is clipped, it is non-linear. This happens when the DC output offset is too small. To fix the problem, we simply increase the DC output offset. Now we can also have the case where the DC offset is too high. Notice that the maximum AC signal swing is clipped, and in that region the output is nonlinear. Now let's go ahead and take a look at some real measurements. Here we're viewing the output DC offset on the oscilloscope. The cursors indicate the minimum and maximum output swing. As the DC offset lowers and it's too small, we can see that the output becomes clipped. This is where it's nonlinear. If I increase the offset, we see we can raise the signal and it's no longer clipped. However, we can do this too much. As I increase the amplitude of the input signal here, we can see that the maximum swing becomes clipped. So our solution to this problem of clipping due to the DC output offset is to center the DC offset. If we center it, we can achieve the maximum input and output voltage swing. So if your supply voltage is 9 volts, then you go with 4.5 volts as your DC offset. Thank you for watching this video, and I hope you learned more about the common emitter transistor amplifier. In the next video, we'll look at some calculations to where we can start picking values for the components shown in the schematic. Thank you again, and I hope you have a great day.